Hi, everybody. I'm going to give everybody a minute or so to get checked in here. I know I've still got a couple connecting to audio, um, and we'll just give people a few minutes or a minute or two here before we start moving forward. My name is Chris Evans. We're talking about soils today, which should be good stuff. It's spring. I work for the Lewis and Clark Conservation District. I've been with the Conservation District just under 23 years now. I went to college in Bozeman, got a degree in geography with a minor in earth science, and I was an inch and a half away from a soils minor, which soils has always been interesting to me. I have a couple of grown kids. I've lived here in Helena since '97 and love working for the Conservation District. So we'll go ahead and get started here today. Let me start my slideshow. So what's under our feet? What's under your feet? I'm going to talk just briefly about conservation districts and their relationship to soils. Districts were formed at the national level in the 1930s in response to the Dust Bowl era. The state of Montana passed legislation creating conservation districts in 1939. Lewis and Clark Conservation District formed in June of 1948. So next year, we're going to be celebrating our 75th anniversary. We are subdivisions of state government, and we are governed by a board of elected unpaid supervisors. Our budget comes in part, a large part of our budget comes from a very small property tax. If you're a landowner in Lewis and Clark County or a homeowner in Lewis and Clark County, most likely, unless you live in the city, the 9 square blocks of the original 1948 city limits, you have a very small amount on your property tax bill that goes to the conservation districts, probably less than a pizza every year. Our mission at the Lewis and Clark District is to provide leadership in the conservation and wise use of soil, water, and related resources to the landowners in Lewis and Clark County. I am going to start with a disclaimer. I'm not a soil scientist. I'm not a soil chemist. I consider myself to be a generalist. I have a very deep interest in the soils and how they form and how we can make them better. But I don't come at this with a real scientific, a real scientific background, other than just the soils that I have done in college. A fun quote that I like to share with people, this is attributed to Paul Harvey, is despite all of our accomplishments, we owe our existence to a 6-inch layer of topsoil and the fact that it rains. And if you take a step back and think about that, that's a pretty amazing thing. Everything we do, everything we have is based on our topsoil and our food, our trees that we make our buildings out of, everything. So that's a fun one. We're going to talk today about 6 major things: soil formation, soil components and their importance, soil limitations and their advantages, making the most of the soil that you have, and determining your soil type. We'll end with some resources, and there will be time for questions throughout this. So when I break for questions, if you want to just unmute yourself and ask questions, feel free. So there's 5 main factors in soil formation. Parent material is the first one. It's the rocks and the minerals that soils weather out from. Topography, terrain, affects the development of soil. The flatter the terrain, typically the deeper the soil development. Gravity plays a role, as does wind and water, moving soil and rocks from steeper slopes to flatter areas. Climate plays a role, how much moisture your area gets, what the temperatures are like. Both play a huge part in soil development. Warm, moist climates have faster developing soil. Colder, dry climates have a slower development of soil. Time is always a factor, no matter what your climate is like. It takes time for the chemical weathering to occur. It takes time for the breakdown of the organic matter that's available for soil development. Any questions about the 5 factors? Okay, hearing none, we'll move on to what's in my soil. So these are the main soil components that we work with, we see in the soil. Mineral components are the largest, around 45%. The other 4 we'll get to in a few minutes, but we'll start with mineral components. Mineral components come from weathering of the parent material, the rocks and the minerals, depending on the source material, the type of rock, and what kind of minerals are in that rock. And depending on the climate, the rocks and their minerals will break down into their component parts, which mainly consist of silicone, oxygen, aluminum, potassium, calcium, magnesium, phosphorus, and other chemical elements. These elements are generally locked up in the crystalline particles and are not directly available to plants until they are broken down. Unlike solid rock, soil particles have pore spaces in between them that allow them to hold water through capillary action. The soil acts like a sponge. This process is important because it allows the soil water, with the help of carbon dioxide in the air, to slowly dissolve the mineral particles and release nutrients. And we call this chemical weathering. This is what they call a soil triangle, and you can see the different percentages on the side. So as the minerals break down, they break down typically into clay-sized particles, which are very small, silt-sized particles, which are the next size up, and sand-sized particles, which are the largest particles in soil. So depending on what your percentages are, and we'll talk a little bit about that later when we look at a video, your soil type is going to fall in one of these categories. This one here, this brown one right in the middle, that's the one we want. The next two components of soil are water and organic matter. Water ranges from 2 to 50%, and that variety in range depends on obviously how much rain we've had or how much snow melt we've got, and it mirrors the air and gases portion down here toward the bottom. So if we have a high water content in our soil, we're going to have low air and gases, and it's because those two things take up the same space. So
MSU.
Whoever's talking, can you mute? So where does soil organic matter come from?
Okay.
Did I miss a page? I'm sorry.
It's just going
Oh, yeah. So hang on a second. I'm going to mute whoever it is that's talking. I thought it could mute him. Anyway, we'll move on. So organic matter is the next component we're going to talk about. It's generally from 1 to 5%, depending on how lucky you get and how much work you've done. Where does soil organic matter come from? It comes from decaying plant litter that's from the surface, and it comes from decaying root material and microorganisms that are in the soil. What is soil organic matter? One of the references that I've read refers to it as the living, the dead, and the very dead. This little blue triangle here is the living soil organic matter, and that's where the microorganisms that we're going to talk about in a bit fall. So the living matter in soil is this little 10% wedge typically. The dead is fresh residue or dead organic matter, deceased microorganisms, insects, worms, old plant roots, crop residue, and any added manures, compost, and that sort of thing. The very dead is that material that's decayed to the point where it's humus. It's the dark brown part of soil typically. It's the organic matter that's really decayed. What is the importance of soil organic matter? It makes soil fertile. As the nutrients decompose into simpler forms, the decomposition frees up the nutrients for the plants to utilize. This conversion makes also increases soil porosity, And that soil porosity is the space between the grains of soil. That when it's big enough, when it's good, it increases infiltration. So if you've ever been on a hillside, I live on a hillside outside of Helena. And when we have the big thunder bumpers that come through in the summertime and we have a deluge of rain, water just runs down the road. And that indicates bad soil porosity, compaction in the case of a road. For growing things, you want good infiltration, good porous soil. So soil organic matter helps increase that. It also helps keep the pH of your soil balanced. So as minerals dissolve from chemical weathering, it buffers the rapid change from acid to base, depending on what minerals are weathering out. And so it keeps that pH kind of buffered or balanced. Soil organic matter improves and stimulates root development of your plants. And it also protects against harmful chemicals, which I think a lot of people don't understand. The better your soil organic matter, the more protection you have from chemicals like soluble aluminum. And there's a lot of pesticides that get hung up in your soil organic matter that then don't infiltrate into your groundwater or run off. So it's good in that regard as well. In the carbon cycle, we're going to talk about 3 different cycles. We're going to start with the carbon cycle. You hear a lot about carbon cycle with climate change discussions and, carbon sequestrations, carbon sinks. So in the carbon cycle, soil organic matter is particularly important. So carbon dioxide is removed from the atmosphere by plants. Sunlight provides plants the energy that they need for the process. Plants, as well as the animals that feed on them, release carbon dioxide back into the atmosphere. The largest amount of carbon that's present on the land is not in living plants, like we think of the rainforest, but it's stored in the soil organic matter. And there's more carbon stored in soil organic matter than in all the plants, animals, and atmosphere combined. So it's really an important part of the carbon cycle. The nitrogen cycle, nitrogen is important for agriculture. It's in the fertilizers that we apply. Whether it's our backyard or on the farm, there is typically a need for more nitrogen in soils. We see gains and losses in nitrogen. Gains come via organic matter, which is converted by bacteria and fungus. We see gains in animal manures, in bacteria that live in soils that can fix nitrogen. They convert nitrogen gas to forms that other organisms can use. And we see gains in trace amounts of rain and snow. We see losses in nitrogen, which would be not a good thing for soil fertility, with removal of crops from the fields. If you have sandy soils, there's a lot of leaching in sandy soils, or if you have tile drainages, that's installed across the Helena Valley. It's amazing how many old tile drains are installed across the valley. So we lose nitrogen in that regard. We lose nitrogen with runoff and erosion, and in conversion by bacteria of the nitrates into nitrous oxide. We all learned about the water cycle, the hydrologic cycle in grade school science class. Soil organic matter is important in this cycle as well. So in the water cycle, water evaporates from soil surface and from living plant leaves, as well as from oceans and lakes, and it returns to the earth, usually far from the point of evaporation as rain and snow. The effect of good soil organic matter in the water cycle is that it enhances water infiltration. We talked about that a little bit already. It increases the storage of water in your soil, and that increase then, of course, can be used by plants more effectively. Water in soils may also percolate into the subsoil and recharge groundwater, something that's particularly important when you're talking about municipal water supplies. So putting a dollar value on soil organic matter is kind of difficult in some regards, but in some ways it's pretty easy. For every 1% of soil organic matter in the top 6 inches of an acre of soil, that equals about 1,000 pounds of nitrogen. And if you, and I'm not sure how dated this amount is, but at 45 cents a pound, that's $450 for every 1% of soil organic matter per acre in your soil. And along with nitrogen comes 100 pounds each of phosphorus, sulfur, and potassium. So your dollar total for that is $500 per acre for every percent of your soil organic matter. The other side benefit, or the value that we see from this, is that increased infiltration. If you've got really good infiltration in your soil, it reduces flooding potential and water pollution and all kinds of other things. So that spongy layer that soil organic matter helps enhance, that soil layer, it's beyond value. So the last two components that we're going to talk about in soil are air and gases, which we said water and air and gases mirror each other. So if there's 2% water, there's probably 48% air and gases. If there's 2% air and gases, there's probably 48% water. And it's just because water takes up the same space that air and gases have in soil. Compacted soils are a problem for root development due to the lack of airspace and also plant available water capacity. So it's good to have that porosity in your soil. You don't want it compacted. The last component we're going to talk about are soil microorganisms. And this one to me is the funnest because just in the last, I don't know, maybe 15 years, this has become really a big thing in the conservation district world. More and more districts across the state are doing soil health projects and workshops. And so we've learned a lot about soil microorganisms, things like bacteria, fungi, algae, protozoa, and nematodes. There is a soil bacteria that I have a hard time pronouncing. I think it's actinomycetes. They're a type of soil bacteria. These are just some fun facts that are responsible for that earthy smell of soil when you're out working in the dirt. That smell, that's those bacteria. There's another one that's Mycobacterium vaccae. It's being studied because it appears to mirror the effect that on our brain neurons that Prozac has. When I was a kid, my mom and I called it soul therapy. That first trip out to the garden in the spring to get your hands in the dirt. There's nothing quite like it. And it's probably got some kind of scientific background. Another fun fact is that a teaspoon of good productive soil generally contains between 100 million and 1 billion bacteria. And that's as much as 2 cows per acre. Bacteria live almost everywhere, including on plants and in soil and on us. They provide nitrogen to plants by helping to decompose other organisms like protozoa, of which a byproduct is nitrogen. Fungi are small, some are even single-celled. They initiate decomposition of organic residue, and in soil, they grow on roots. Many of them grow on roots that take up water and the nutrients that then feed the plant. Algae converts light into complex molecules like sugars, which they use for energy and to help build other molecules. They form mutually beneficial relationships. Nematodes are simple soil animals that look like tiny worms. I probably should have advanced this already. So here's some nematodes in this picture. They usually live in the water film around soil aggregates. Some are considered pests that allow harmful bacteria into the roots on plants, but many are beneficial they break down the organic residue and feed on the fungi, bacteria, and protozoa. Along with protozoa, nematodes feeding on fungi and bacteria help convert nitrogen into forms for plant use. As much as 50% or more of mineralized nitrogen comes from the nematode feeding. Protozoa are single-celled animals that move around in the soil. They can only be seen with a microscope. They feed on organic materials and are believed to be responsible for releasing nutrients from organic molecules. Worms, insects, and other animals. And did you know that there are multiple kinds of earthworms? There's night crawlers, there's field and garden worms, and there's manure worms or red worms. and they all have different feeding habitats. Some worms feed on plant residue on the soil surface. Some feed on organic matter that are already mixed with the soil, and along with plant roots and other soil organisms, they do improve infiltration of water and the soil aeration. Then there's these guys over here, the bigger animals that create burrows. Those obviously improve water infiltration, just more in a flood type rather than soaking up like a sponge. Any questions on that section so far? Anybody? All right, moving on. So what kind of soil do we want? Good soil should have a good supply of nutrients throughout the growing season. So we want a good fertile soil. We want a good soil. We want a soil with good tilth or ease of tillage, fitness as a seed bed, so that the plant roots can develop with the least amount of effort. A soil with good tilth is more spongy and less compact than one with poor tilth, and promotes rainfall infiltration and water storage for plants to use later. For good root growth and drainage, we want a soil with sufficient depth before a compact layer or bedrock is reached. I know that in the Helena area, we have some clay lenses that are a problem in some soils across the valley. Typically in the valley, though it's depending on where you are, there's gravels that you hit gravel before you actually hit solid rock. And so the soils can be deeper. They're maybe not the best quality, but they're deeper. We want a soil to be well drained. That's where the gravel comes in nice, so that it dries out enough in the spring and during following rains to permit timely activities. And it's essential that oxygen is able to enter the root zone, and just as important that carbon dioxide leaves. Good soil should have low populations of plant disease and parasitic organisms. There should be low weed pressure, especially of the aggressive and hard to control weeds. Most soil organisms are beneficial, and we want high amounts of organisms that help plant growth, such as earthworms and many bacteria and fungi. We want a soil that's free of chemicals that might harm the plant. These can occur naturally, such as soluble aluminum that are in very acidic soils, or excess salts and sodium in arid soils. Potentially harmful chemicals are also introduced by human activities, such as fuel oil spills, or when they apply sewage sludge with high concentrations of toxic elements. And we can over fertilize. You know, if you read some of the literature, a lot of the algae blooms that we see out there are from people over applying fertilizer, and it's also not a great thing for the soil itself to over fertilize. Finally, a high quality soil should resist being degraded. It should be able to recover quickly after unfavorable changes like compaction. So soil limitations. We're going to talk about 4 basic soil types: sandy, clay, silty, and loamy soils. Some of the limitations with sandy soils are that they dry out quickly in the summer. Nutrients and water can leach away more quickly, and often they're acidic soils. Clay soils hold water well, but they can be slow to drain. They're slower to warm up in the spring, so it takes a little longer for things to germinate. They compact more easily, and they tend to be alkaline. Silty soils are sort of a balance between sandy and clay. Infiltration of water can be poor, but it can be okay depending on what your concentrations of sand are in that silty soil. There's a greater chance of forming a crust. When I was a kid, I grew up east of Shoto on a dryland wheat farm, and we had one field that to this day still has these patches that can be bare if they're not, if it's the wrong time of year and when you seed. And when we were planting it to CRP 10 years ago, I was up there looking at it, and you could actually see, because it had been farmed with barley before, and the crust was dried out on that field in that section. And if you broke up that crust and you picked it up, you could actually see germinated barley seed in that crust that had never actually been able to get through that crust of soil. So we don't want crust forming soils. Silty soils can also be fairly easily compacted, although not as easily as clay soils. Loamy soils, those are the ones we want. Some loams can contain a lot of rocks that affect harvesting crops, but in general, loam soils are what we want. Any questions on soil limitations? Speak up. Right, we're going to talk soil advantages. Sandy soils warm quickly in the spring. And they're well drained, I guess, too. That's really the only main advantage of sandy soils. They warm quickly in the spring and they're well drained. Clay soils hold on to nutrients really well. They're great for growing things that need a lot of water, but they tend to not be well drained, so you got to be careful with that. Silty soils can be fertile. If they're a more fertile silty soil, they'll hold on to nutrients better than sandy soils. They have a pretty good water holding capacity, and they're easier to work than clay soils are. Loamy soils are drought resistant. They warm up faster than clay soils. They can hold on to nutrients well, and they have good air and water infiltration capacity. Any questions on soil advantages, generally speaking? So how do we make the most of the soil we've got? With sandy soils, you want to water less often and use fertilizer less often. But let me back up. With sandy soils, you want to water often and not as much water at a time. You want to use less fertilizer at a time because of that leaching capacity. Adding organic matter for nutrient holding is always a good thing. You want to incorporate really well-rotted compost and carbon-rich fertilizer. A note on compost. There were several years that I sold trees for the conservation district in our tree program. And I had a customer who went, and she lived in the North Valley where she didn't have much in the way of soils. She went and bought truckloads of compost, and I don't know where she bought it from. It doesn't really matter now. It was 10 years ago or better. She incorporated that compost into each of the holes that she planted her trees in, and by fall, her trees were dead. And it was because the compost was not well rotted. It was what they would consider hot compost. It just wasn't done yet. It wasn't really compost yet. So you want to be real careful where you get your compost from. Make sure it's very well decomposed. Clay soils, you want to encourage microbial development for aeration. Amend it well with rotted compost. I don't know that there's anything that good compost won't solve. Avoid compaction by not working the soil when it's wet. Use a cover crop in the off season. This is kind of a new one in Montana for home gardens, the use of cover crops. I've got a link that I'll share with you guys later, an MSU extension link from Broadwater County, where they have some recommendations for using cover crops in the off season. For silty soils, you want to avoid working them when they're wet so that you can reduce compaction risk. You want to increase your soil organic matter by adding well-rotted compost. Loamy soils, they're pretty good, but to keep them good and to make them better, you want to encourage that soil microbial development, and you want to maintain your soil quality. Adding compost to your garden, it adds a primary energy source for those microorganisms. They need a lot of organic matter to thrive. So adding compost will ensure that they have a steady supply of organic matter. The cover crops that we talked about briefly already: clover, buckwheat, oats, barley, winter wheat, and winter rye are all recommended through that article that I'll post the link for later. There are some problems with some of them that have deeper root systems. You want to make sure that they're turned over in the spring, so that they don't impede what you're trying to plant. Some of them can be deeper rooted than others. One of the things I've also read is that cover crops can help in really dry climates. They keep the soil moisture better because you've got a cover in place during the dry period. You want to keep your soil well watered. We talked about that a little bit. Microbes, they'll thrive in moderate temperatures, moist soils. If soil is left bare and dry, high temperatures can kill your microorganisms. Avoid physical disturbances. Anytime the soil is disturbed through tilling or compaction, it can disrupt that structure of the soil and the habitat of the microorganisms living within. Mulch your beds. Mulching with organic matter like leaves, pine needles, and straw will help retain moisture in your soil while adding organic matter back into it. Avoid pesticides as much as possible. Chemical pesticides, herbicides, fungicides, and fertilizers can kill entire populations of some microorganisms in our soils. So choose organic fertilizers instead, such as compost or manure, which release nutrients into the soil over time and don't leave long-term residues like so many of the chemical fertilizers. A note on pollinators, if you can wait as long as you can in the spring to remove residue and litter until we've had some warmer temperatures, several days in a row, pollinators and other beneficial creatures overwinter in that litter. So keeping those undisturbed for a little while helps them. And who doesn't want to help the pollinators? All right. So soil testing. There's a couple of like quick and dirty home tests that you can do that I'm going to show you videos for. And then there's some testing laboratories that I'll show you the links to as well. Any questions before we get started on the testing? Okay. This is the first time I've done a video on a Zoom that's embedded in a PowerPoint. So let's hope it goes flawlessly.
Hey, this is Joe with Grow It Build It, and today I'm going to show you a quick and dirty soil test. Knowing what kind of soil you have in a vegetable garden or flower bed is very important. Some plants can't grow in certain types of soil like clay or sand, so I'm going to show you a quick and dirty test that you can perform that will provide you with enough information to get a good approximation of your soil type. This is kind of like a good exploratory test for like where you want to build a vegetable garden, for example. You can do this test in 5 minutes in multiple places of your yard and figure out which one's going to have the best soil for a garden. And it's an exploratory test. It's not a full-blown thing, but it'll get you pretty close to home. So let's get into it. Okay, the materials needed for this two-part test are a tape measure, some kind of a shovel or a trowel, and a water bottle. I like a spray water bottle because you need to be able to control how much water you are using. Now, normally you want to dig down a little bit to get your first soil sample here, but I am just scraping the surface because it's a demonstration. But I'm going to get a handful of soil and put a little water with it. And this is part one of a two-part test. But what I'm going to be doing now is, you remove any leaves or twigs or sticks or obvious organic matter, and you start working the soil into a ball, adding a little bit of water as you need to make it form into, a ball. And if you find any pebbles or large, rocks or anything, remove those and compensate it for soil if you need to. The consistency you're going for on this is kind of like Play-Doh or silly putty. And what you'll do is you just work it back and forth like kneading dough. And it's going to start sticking to your hands, but as you keep working it, once it stops sticking to your hands, that's usually a sign that it is ready to turn into a ribbon. And that's what this test is a ribbon test. So you see how I'm forming it in my hands right now. I'm starting to press the soil in between my index finger with my thumb, and that's making a little ribbon. I squeeze some ribbon, I move the whole mass up, and I squeeze some more. And eventually this is going to curl over my hand and break like it just did. And that's what we're going for. The length of the ribbon is part one of the test. And I do this until I get at least a couple pieces of ribbon. And often I will repeat the test because it's, the more samples you do, the better. And it really doesn't take long to do this. Now, if, again, just work it until it stops sticking to your hands, and the consistency should feel like silly putty. But the ribbon length will give you a good idea of what your base material is. The shorter the ribbon, the more sandy it should be, and the longer the ribbon, the more clay it should be, in a nutshell. But anyways, you'd be surprised as to how much it can vary just within 10 feet on your property. Like what I'm going to show you right here, this is an example from one hole, from the top half of the hole. I have ribbons that are over 2 inches, and then if I go to the other side here, it's much sandier when I went further down in the hole, and you know, the ribbons were less than 2 inches. So just kind of interesting. But anyways, that's part one, and that's done. So make a mental note how long your ribbon is. For part two, what we're going to do is be actually trying to feel the texture. So we're going to break off a little piece of our ribbon and put it in the palm of our hand. Now you're going to put a lot of water into there and start smearing it around your hand. And you're basically turning it into a thin film of soil on your hand and really evaluating the texture as you do so. You'll probably have to add water a couple of times, but you're really just trying to see what does it feel like. And the reference points that are good to examine here is, does it feel like rubbing sand between your fingers, or sugar, or flour? And the reason why we say that is because if it feels like sugar, like dry sugar in between your fingers, then it's basically going to be, you would call that very gritty. If it feels like rubbing dry flour between your fingers, that would be smooth. And if not one of those feels or touches dominates, then it's neither. And so based on the ribbon length and that, you can classify what soil you have. So on our website article that I'll have linked below, or you could just Google Grow It, Build It soil texture, I have this little matrix which has the ribbon length on the y-axis and the texture on the x-axis. You just match those two up, and that'll tell you what kind of soil you have, which corresponds to the NRCS pyramid, which is shown above there. So go to our website and you can find this information. I'll put links down below. But it gets you pretty close to home. Now, if you decide you're going to actually build your garden there and you think maybe you'd like to go a little more in depth, I will be having a detailed soil test coming out soon on.
Right. So that was the ribbon test. And I do have a link to that that I'll share a little bit later here.
Getting the actual percentages.
All right. This next one, I think, is probably the funnest test. It's called the mason jar soil test. And all you need is a jar that's like a canning jar, something with straight sides. It doesn't matter how big or how well, probably matters. You want it probably quart sized or bigger. And you fill it. Well, he'll take you through it. It's kind of magic. I enjoy this one.
Hey, this is Joe with Grow It, Build It, and today I'm going to tell you how to determine how much clay, silt, and sand you have in your soil. So if you're watching this, you probably have some kind of an idea or indication as to what kind of soil you have, whether or not it's draining well, or it's extra sticky, or it changes versus depth. And what I'm going to show you today is a step-by-step process to determine the exact percentages of how much sand, silt, and clay you have in your soil, and I'll also talk about ways to improve it. This method works really well. It has a couple other steps than what you may have seen previously out there. I also want to mention that if you are having any kind of drainage issues or suspect it, you may want to conduct the drainage test at the same time. I have a video on that. I'll put a card in the top right. But these two tests go hand in hand, because if your soil drains at different rates versus depth, you can test them right at the same time you're doing both tests. So let's get into it. Okay, so for materials required, the first thing you're going to need is some kind of a shovel or a spade of some sort. You're going to need a couple of buckets for this test. You know, a 5-gallon one's good, and then another one that's, you know, decent sized. A common kitchen strainer, and if it can fit in your bucket, so much the better. We'll see why in a minute. You'll need a jar with vertical walls. Mason jars or canning jars are commonly used for good reason. Also, we're going to need some kind of powdered dishwashing detergent that you use in the dishwasher. You could probably use dish soap in a pinch, but I've seen universities recommend that this is just better at separating out the clay and silt particles. And then finally, you're going to need a tape measure or ruler and a marker. And if your tape measure has a metric on it, so much the better. Okay, so step one, we are going to get our soil sample. So you're going to want to dig down, you know, a decent cross section, at least 6 inches or so. And again, if you're doing the soil drainage test at the same time, you may want to go more or separate samples, whatever. But anyways, mix up your soil sample very well and try to break up and identify if there's any major rocks or organic matter you can remove. The next step, is going to be to actually put some of that soil through a strainer. Now, don't be afraid, you don't need to do all your soil, just enough for filling a jar halfway or so. This may seem like overkill to separate out the rocks and really break up any compacted particles, but I can assure you it's well worth your time. It really doesn't take long, maybe 10-15 minutes, but when I haven't done this in the past, when I'm dealing with compacted soil, it can impact the results. So on the left here is a sample that was put through a strainer, and there's like no air gaps. It's perfectly, there's a perfect gradient. On the one on the right, you can see those gaps there indicating some kind of compaction. And this one also had some little balls of clay like below the letter S right there. You see the light color, and down at the bottom below M, that's clay. That shouldn't be there. That should be at the top. So it's just a good idea. It helps you find any other rocks or anything to pull out, and it just gets you a very nice product at the end. Okay, so the next step is going to be filling our jars. Now, all you have to do for this is to fill your jar like roughly a third to halfway. You don't need to go more than that. Depending on your jar size, you want to go 2 to 3 inches, so 50 millimeters, 75 millimeters, something like that. And you know, again, the sifted soil really makes this easy to do. Now after that, it's going to get easier. All we have to do is fill our jars with water near the top, not all the way, maybe about 75-80%. And that way, when you shake it up, it has some room to actually mix. And you're also going to add a big scoop, like a tablespoon worth of the powdered dishwasher detergent at this time. And this really does help separate out the particles from one another once we shake it up. And that's exactly what our next step is going to be, is to shake them vigorously. You want to do this for about a minute for a jar. And, you know, the more effort you put into it, the better it's going to be. Okay, so now we're just going to set it down and start letting it settle out. And at 60 seconds, we'll just take our marker and mark the sand layer. 2 hours, you'll mark the silt layer. And then roughly like 2 days later, you can mark the clay layer. It could take more than 2 days for the clay to settle out. I've had it take about 3 or 4 days before. And I want to point out, you know, when you guys actually go to do this test for real, after watching this, if you just want a quick reference, Google Grow It, Build It, Mason Jar Soil Test, and you'll get to our article that has all this information in a list form. So it's easy to reference. But it's kind of fun doing this test though, because the sand really does settle out like immediately. Like I just set this jar down after shaking it. So at 60 seconds though, you're going to mark 2 layers, and you can see where the sand is, and then above it's like a uniform milky substance. And then 2 hours later we come back, now we have a new layer to mark, and that's going to be the silt layers. And then anyways, when we come back after a couple days, I've already marked the clay layers, which, you know, the jar on the right had almost no clay. The one on the left had a thin layer. What's interesting about these two samples is the one on the left, you can see it has very coarse sand at the bottom, then a thin layer of silt, and then a thinner layer of clay. That's from the vegetable garden. And it's also darker color, indicating some organic matter in the water. The jar on the right is about 10 feet away in my lawn. It has very fine sand and then a bunch of silt and almost no clay. It's kind of interesting in how that plays out. It's kind of fun to take multiple samples is all I'm saying. But okay, now we are going to go calculate our results. So to do this, I'm going to go in detail on this, so bear with me here. But we're just going to be measuring the height from the bottom of the jar to each of our marks. So I had 43 millimeters of sand, 63 millimeters silt, 68 millimeters clay. So that's the total height. Like the clay is the total height of everything, my sample. So to calculate the percentage of sand, we just need to take the height of the sand, 43 divided by 68, which is the total height, the height of the clay. We get 63.2%. To do this for the silt, we need to take the height of the silt minus the height of the sand. So 63 minus 43 is 20, divided by the overall height of 68 millimeters gives you 29.4%. And finally, to do the clay, we take the height of the clay, divided by the height of the silt, divided by the overall 68 millimeters, and we get 7.4%. Okay, so now we've got our percentages, give or take a rounding error here or there. What do we do with them? Well, we can go to the USDA's soil pyramid website, which I'll have a link to below, as well as in the article I referenced. And you put in the percentage of sand and the percentage of clay, and it will put on their little pyramid exactly where you fall. So this sample I just entered in here is sandy loam, which is, it's better than I thought it would be. Or I expected to have a clay soil because it didn't drain well. And turns out I just have a compacted sandy loam. All right, so what do you do if you are in a bad zone? Well, if you're in like a real sandy area,
We're going to stop
you
it
just need to
there. I
amend
do have the links to those videos in the resources page that I'll share with you guys in a minute. But the other,
compost.
whoop, a little crazy there. The other testing resource we have here in Helena is the Energy Laboratory. They will do a soil test for you. I'm not going to tell you how to prepare it because I'm sure I'll get something wrong. They will tell you exactly how to prepare the sample when you're submitting it, and they will test it for a number of things, including what your soil type is, the fertility. They have a lot of different testing capabilities that you can do. Any questions on those 3 testing things yet from anybody? Okay. So we're almost to the end. These are the resources pages that I told you about. A lot of the information on, or a lot of the structure for the presentation I did today came from this first one, the Sustainable Agriculture Research and Education site. They have an incredible section on soils that is incredibly in depth, and it's a great site. The MSU Extension resources, these are the soil sampling, home gardening, and this is the this is the same one as the one down here. Huh. Whoops, I duplicated this one. This first Broadwater one, actually both the Broadwater ones are the Broadwater County Extension article on cover cropping that are really good. And if I can figure out how to put these in the chat, I will. I'm sure that we're recording this too, and it'll be up at the library, and the Conservation District will have a link to it on our website as well. This is another article on cover cropping in home gardens. It's out of Wisconsin Extension, so might be worth having a look at as well if you're interested in cover cropping. The soil testing information, this is the link to the hand ribbon soil test on their website. The video is hosted on YouTube, but you can access it from this page, and they go through all of the procedures that he talked about. The mason jar test is here. The Mont guides for extension, actually it's the Land Resources Department at Montana State University. This is the soil test lab link that they have for a lot of different locations that you can send soil samples off to for testing. This NRCS link here is the one that he used in the most mason jar soil test, where he put in his percentages. And then web soil survey. A word about web soil survey. I used to work for NRCS back in the old days, and I worked in the Miles City office where they were in the midst of doing a soil survey. And I will tell you, web soil survey is a great resource for very general information. When soil scientists go to work to do a web soil survey or a soil survey, they start with air photo images, and they draw lines. They draw lines around vegetation types and stream beds and high steepness terrain. And they sort of then, based on that and the geologic map that goes along with it, they extrapolate what they expect for a soil type. Then they go out and dig soil test pits and do core sampling. But they don't, it's not like they sample, every 5 feet. They just test their extrapolations. And so it's a good place to start. But if you're really interested in what type of soil you have, I would recommend that you use one of those other resources and take a look at, or have them take a look at your soils to tell you what you have, and then you'll know what better to do with it as far as building it and making it better. Right, we've reached the end. Does anybody have any questions, or can I clarify?
I do. I have a question.
Hi, Cindy. Yeah.
Hi, Chris. I would like to know, on the 3 different kinds of worms, which one is the best for a vegetable garden? And I know you can buy night crawlers and red wigglers, and garden worms, I just assume, are there to begin with if you don't till all the time.
Yeah.
You want to add any of them to the garden?
Night crawlers can be kind of a nightmare for people as far as creating problems on their lawns. I don't really care about that. I don't see night crawlers so often around here. When I lived in Miles City, we saw night crawlers a lot. I think the garden earthworms that are just there, if you build your soil, you're gonna see more and more worms. The red worms tend to be more the surface. They tend to eat the vegetation. I know a lot of people who do worm composting. So they have a red worm composter that they feed their kitchen scraps and stuff to. And then it creates not just nice humusy dirt, but it creates the tea sort of thing that they feed their plants. So to me, the earthworms are the ones we want. They're the ones I want.
Okay. All right. Thank you.
Yeah. Yeah. Go ahead, and if you've got questions and you're shy about turning on your mic, go ahead and put it in the chat. My contact information is here on the screen. Like I say, I'm a generalist, but I'm one of those people. My job seems like about 90% of my job is helping hook people into the resources they're looking for. Our website is a pretty decent one. We've worked really hard at putting the resources on there for programs and landowner resources that people are looking for. So if you're looking for something specific on our website and can't find it, let me know and I can either direct you to it or we can add that, because I'm always looking for more feedback. And just another plug before we wrap up for the night. Our website, we are in the midst of, we're always in the midst of doing a resource assessment. We do a local work group meeting every year to help NRCS prioritize direction of their funding. So if for agriculture folks, for large scale ag folks, but part of our planning is also for smaller acreage landowners. And so one of the things that pops up when you go to our website is a resource concern survey. If you have feedback for us, pop it on that resource concern survey. I do look at those when I see them come in. And I do try to put people in touch with resources that they're looking for. And I add their concerns to our resource concern list at the district. So every year we do a planning process to try to figure out how to spend the money that we get, which isn't a ton of funding. We do support 2 full-time staff. And so we're always scrounging for grant money and program money. So that's just my plug for the Conservation District website. So anything else from anybody? Any other questions or comments? Kind of a quiet bunch this afternoon.
Chris, I have a question.
Sure, Kurt, what's up?
I have a problem with root maggots when growing turnips, and what I've read is it says to add beneficial nematodes. How would I do that?
I'm not sure about the resources to purchase the beneficial nematodes. You can get a lot of different kinds of critters like that online. What I would recommend that you do is contact the county extension office and see if they have a source for those. Matt Walter is the extension agent for Lewis and Clark County, and I'd be willing to bet the Master Gardeners folks, they probably have some good sources for those kinds of good critters, the beneficial critters. So,
All right, thanks. I'll give them out a shout.
Yeah, you bet. Like I say, I'm not the one with all the answers. Usually I'm the one that knows who has the answers, which is almost as good. All right. Anybody else? Okie dokie. Hey, thanks everybody for being on today. And as always, just give me a call if you have any questions about anything. I'll try to put you in touch with the right people. Have a good day.